So as I alluded to on Wednesday, when we're talking about the different forms of exponentials and logs, you need to have this because just today, we're going to use it 1, 2, 3, 4, 5, 6, 7, 8 times just today. And so we're going to use this on every single problem that we have in this unit. Okay? So if we have in exponential form, that's the upper one. The upper one is exponential form. So we'll have a base, and that we'll know it's the base because it will have the exponent attached to it. And that's going to equal some argument. Then if we are if it's an exponential equation and we need to solve it, we're going to manipulate it a little bit, get it to look like this, and then put it in log form. So we need to know how to do that. If it's a logarithmic, which we'll get to later on today, if it's in logarithmic form, we're going to make it look like this. Then we're going to put it in exponential form. And that's how we're going to solve it. This tool, memorizing that these two relationships, that the base with an exponent equals argument is the same as log of the base of the argument equals exponent, is crucial. Okay? Everybody got it written down? All right, let's do it. Here we go. Okay? So we're going to solve exponential equations today. And then in about 10 minutes, we're going to solve logarithmic equations. Okay? So the first step in both is we need to isolate whatever it is that we have. So meaning we need to get the exponented term all by itself on its own side, or we need to get the log term all by itself on its own side. Okay? That's what I mean by isolate. So if it's an exponential, we need to get rid of everything but the exponented term. 3 to the x power, right there, that is our exponented term. Okay? So that's what I need to get by itself. So I'm going to add 4 to both sides. That then gives me 3 to the x power equals 10. Agreed? Okay. I have now isolated either my exponent term or my log term. So step number 1 is done. Step number 2 says I'm going to switch forms. This one's in exponential form, so I need to switch it to logarithmic form. If I switch it to logarithmic form, I'd have, log, what would the base be? 3 of 10, because 10 is my argument, equals my exponent, which was, in this case, x. Okay. Now, we can solve it. Is there an exponent that can go on to 3 to get me 10? No, right? Okay? So it's not an easy one, so it's a calculator one. So then now we're going to use change of base here on this one. And we're going to say here that, we're going to say here that x is equal to log of 10 divided by log of 3, or natural log of 10 divided by natural log of 3. I get 2.09590327, which then will round so I get that. Then, here's the kicker. So we need to go back and we need to check that. Now, if we use the rounded one in our check, our answer is going to be really close to, so like in this case, our calculator would be really close to 6. Okay? If we use the exact one, if we leave that on our calculator, then it's going to be exactly 6. Okay? So if I go 3 raised to the 2.096 power, I get I get 10.0010267. Then I subtract 4, and I get 6.001062697. Okay? Which is 6. If I would have used it exactly without rounding it, it would have been exactly 6. So it's checked out. It works. Okay? Good times. You try those two. So I got that for the first one. So then I would have to multiply that by 4, and add 2, and take 4 to that power, and I get 54. If I use the rounded one, I would go 0.219 times 4 plus 2, 4 raised to that power. I get 53.892. I used the wrong.
What are you looking at?
How did I get my answer to spell like 55 instead? I'm still close enough.
55 is not close to 54 in terms of math.
You got
53.89. Yeah. 1/8 for the other one. Yep, I gotta scroll down and make my check. So 2 minus 3 times my answer is that. Take e to that power. I'm going to multiply that by 2. I'm going to subtract 3. And I get 11. With logs comes 3 different styles, 3 different forms of types of equations. Okay? With exponentials, it's going to be 1x. You're going to have one exponented term somewhere in it. Solve. Go. Okay? Right? If you have 2, then somehow you would be able to get the same base of them, and I'll show you that when we get to double logs here. Okay? In logs, if you have a single solitary log in your equation somewhere, same steps as the exponentials. Isolate, switch, solve, check. Same steps as we did back there. Isolate, switch, solve, and check. Okay? So isolate first, I would subtract 3. I've now got my not my exponent, my log term is isolated. Okay? If it helps, remembering back from on Wednesday, if there's no base written, we assume it to be base 10. Okay? That's going to help us in the switch process now. So now I'm going to switch. So my base is 10. My exponent is 2. My argument is x minus 3. Solving this, 10 squared, 100. So I got 100 equals x minus 3, add 3. Equals x. Checking it, 103 minus 3 is 100. Log of 100 is 2. 2 plus 3 is 5. 5 is equal to 5. Same set. Okay. You try that one. Log term isolated, not isolated? Isolated, okay? So that means I can switch forms with it. What does it become? Four to the 6th power equals 3x. 4 to the 6th power. 4096? 4, 13, 19, not divisible by 3. Did you know that? You know that trick? if you add up all of the digits of a number, if that sum is divisible by 3, then the number is divisible by 3. Only for 3. So it's not divisible by 3. So let's make it easy on ourselves and leave it in fraction form. And you are crazy. It is solved right there. In decimal form? Is it rounded to 3 decimal places? That works. Okay. Check again. 4,096 divided by 3 times 3 is 4,096. Log base 4 of 4,096 is 6. Checks out. Good thing. Next flavor of problem is going to be log equals log. I will also say that this works for exponential. Yeah, this one. This also works for also works in this case too. Okay? If you have the case where you've got base equals base, then exponent has to equal exponent. Same thing here. If you're in a log case, if you've got base equaling base, then argument has to equal argument. So 2 minus x has to equal 5x. Now that only works in base equals base. In logs, it's got to be written that way. In exponentials, you might be able to manipulate one of your bases to get it to be equaling base equals base. What I mean by that is, like, if you have, I'll go over here. If you have 4 to the x power equals 2 to the 5 plus 3x power. Those aren't the same bases. But 4 can be written as 2 squared, which means that would be 2 to the 2x power. And now they're in the same base. Okay? In logs, it's got to be given to you with the same base, because we can't manipulate a log like that. Okay? So if that's the case, then I would add x to both sides. Divide by 6 on both sides. And I get 1/3 equals x. Two minus 1/3 is 5/3. 1/3 times 5 is 5/3. Checking it.
Just keep on going.
Remember, you gotta check it at the end.
Yes.
So 2 is like 6/3, right?
Sweet. So that's how we solve this thing.
That's done. You want it to be hard, but it's not. Okay? In this case.
So we just ignore like the law.
Yeah, because those parts cancel each other out because they're the same on both sides.
We always do this to the other.
provided the bases are the same. Then you can't do it. Yeah. That's like this. Then the exponent would have to be the same. In logs or in exponentials? In logs, if the bases aren't the same, you're done. In exponentials, you got to make it, you can possibly get it so that the bases are the same. Using your exponent rules that we went over last semester. It was fun. Try that one. Do we have the same base? Yeah, both are base E, right? Yeah. So since we have the same base, then our arguments need to be the same. So 5 minus 2x has to equal 5x plus 3. We can add 2x to both sides. And at the same time, we can subtract 3, because we're smart like that. So we get 2 sevenths. Checking it, 5 minus 4 sevenths is 31 sevenths. 10 sevenths plus 21 sevenths is 31 sevenths. Works out. Love it. You try that one. That one. This one. I don't know, somebody that named their child Corduroy. Base is the same? Okay, so if base is the same, means we can do that. Which means we can that, which means we have that, which means we get that, right? Anybody check it? Ooh, okay, let's check it. Let's check. What log base 2 of, that'd be negative 10, right? Right? Okay. What exponent can I put on positive 2 and get me negative 10? Can't have a negative argument, right? Got to be a positive argument, right? So what happens to negative 2? So what's my answer? No solution. That, ladies and gentlemen, is why it is so important to do that step number 4. Everybody in this room was 100% confident that they had gotten it right because you did 3/4 of the work. Okay? In logs, because of that rule that we talked about on Wednesday, where the base has to be positive and the argument has to be positive, because of that rule, you have got to check. So that's kind of a big key one, and that's why I put it there. Yep. This week, your homework was the research of the logarithmic equation, which we were asked to do yesterday, so make sure you get that turned in before you leave today. And you can start working, you can continue working on the paint worksheet. Those aren't due until next week, Friday.